Hey there, Year 901, Mr. Herman here, and this is the first video for the new topic of Topic 7, Quadratic Expressions and Equations, and this is Lesson 5a, Expanding Expressions. The learning goals for this lesson is to review how to apply the distributive law to expand brackets, and the success criteria is to be able to expand binomial products including perfect squares, and to be able to form a difference of perfect squares by expansion. Now, expanding expressions we've already seen before within the topic of algebra. We can have a look into like terms, which we've seen before. And a like term is just terms that have the same pronumeral part. Pronumeral just meaning letter or same sets of letters. The formal way of saying this is pronumeral. They can be collected, so you can either add them or subtract them to form a single term. So for example, 7x minus 11x, the x's are like terms, or 7x and minus 11x are like terms because of the x, and so 7 minus 11 is negative 4, and the x is the commonality, so we have negative 4x. With 4a squared b minus 7ba squared, the a squared b and ba squared, despite the fact the positionings are flipped around, they're still like terms. So 4 minus 7 is negative 3, and then we have a squared b, or this can be written as negative 3ba squared. Makes no difference, they both mean the same thing. Now we're going to be looking into the distributive law, and this law is used to expand out brackets. I always like to think of expanding brackets as getting rid of the brackets, turning one from bracketed form into non-bracketed form. Factorizing, on the other hand, the reverse process of this is trying to put brackets into place, and we'll look into that a little bit later. For now, a multiplied by b plus c within a bracket. This here, we're distributing that a, and that's why it's called the distributive law. We're distributing that a to both the b and the c, and so this just means a times b is just ab plus a times c, which is just ac, what we have here. That is this distribution that's going out. Similarly, if you have a subtraction in the middle of b and c, same concept, a times b, which is ab, but in this case, because it's positive a times negative c, we end up with a negative ac, because a positive times a negative will result in a negative term. It's ab minus ac. Now, where we extend on this is when you have both terms, or both collection of terms within brackets. So in this case, we have an AB and we have a C and D, both of them in brackets, and they're being multiplied with each other. So what's going on is we are distributing this these terms out, but we're distributing the A with C and D and the B with C and D. So in other words, whatever term we have within the first bracket, that gets distributed out to the C. So we have the A times the C, and also with the D. So we have A times D. And then the B will be the next thing that gets distributed out. So B to C first, and then B to D. Now we use this little acronym called FOIL. Now I'm not too sure if you've heard of this one before, or you've seen it before and you don't remember. This just means first outside, inside, last. Okay, so the first term gets multiplied with the first term of the second bracket. So first term in the first bracket multiplied with the first term in the second bracket. So that's where the first comes in. Then the first term gets multiplied with the outside term within the second bracket. So this is the O, the outside. So this is just a good way of remembering the order. Then we have the inside two terms gets multiplied, and then the last term, so the second term with the last one. FOIL. This is the order of how we expand this out. And so what we end up getting is AC plus, because it's a positive times a positive, plus AD plus B times C, which is the next one, BC, plus B times D. Which we can see right here. So this is just the expanded version of the bracketed expression using the distributive law. That was a bit of a tongue twister. Okay, now with this in mind, this A, B, and C, D, this is called a binomial product. Okay, so product just means multiplication. They're being multiplied with each other. And binomial, it means that because both terms within the bracket, there's two of them, there's two terms, that's where that bi comes from. So bi Latin is meaning two, so binomial product is what we call this. Yeah, okay, fancy words, I know, but we all had to make up words for these, and back in the day, this is what terms they just put on, and they just kind of stuck around. The next set of things we're going to be looking at is perfect squares. So a plus b all squared. This is just a plus b times a plus b. Now again, this is where the first outside, inside, last comes into play. So we do that, do this, and do this. And what we end up getting is a squared plus 2ab plus b squared. This right here, you're going to see this quite a lot if you decide to take the specialist maths and the maths methods trajectory when it comes into choosing your maths. You would have to pretty much have this in the back of your head, because this is quite a common equation that we use quite a bit. Now, why is it a squared plus 2ab plus b squared? When you expand this out, so a plus b, we end up getting first, so a times a, which is the a squared. Second is the outside, a times b, which is ab. The inside, which is ba, and then the last one, which is b squared. So you can see that this looks a little bit different to this, and this is because we can collect these like terms of a and b and b and a. A and b, ba are the same thing, and there are two lots of them. There's one here and there's another one here. So what we end up with is a squared plus two lots of ab or ba, generally it's ab, plus the b squared, which is what we have here. Okay, this right here, a's and b's might be replaced with different letters and numbers, or a combination of two of them. You can jump straight to this here if you know what a is and you know what b is. You just simply replace a and b with whatever you get. Okay, and we're gonna rely on this and the second one to help us tackle some of the questions. So the other one is the difference of a and b all squared. Again, when expanded out, I'm not going to show you the process, but you end up getting a squared minus 2ab. Now, a lot of people think it's a squared minus 2ab minus b squared, but it is plus b squared. And this is because when you do the expansion out, negative b times negative b gives us a positive b squared. Okay, so just be careful with this. If you can memorize these two coming from each of these, you'll be fine. The last one is the difference of perfect squares, also known as DOPs. So this here is if we have a plus b and we multiply this with a minus b, then we end up getting a squared minus b squared. So what happens to that term in the middle? We're so used to this 2ab minus 2ab or plus 2ab. When you expand this one out, again, first, outside, inside, last, we get a squared. Now this is a times negative b, so it's minus ab. and b times a, so plus ba minus b squared. So we have a minus ab plus ba, or plus ab. These cancel out. We have a ba and we take away a ba. So what we're left with is just a squared minus b squared. And this is where the term difference, there's a difference of perfect squares. This is a perfect square and this is a perfect square. So it's a difference of these two perfect squares. Let's go ahead and look at some of these examples. We're going to expand and simplify where possible. Where possible being the key word. The first one here, we have -3 multiplied by 5 minus x minus 5, sorry, within the bracket. So this just gets distributed out to both the first and the second term, and because it's just one term by itself, that's all we have to care about. So -3 times positive x, this ends up being -3x, and -3 times -5 gives us positive 15. Nice and simple one, -3x plus 15. For b, we have 2x bracket 1 minus x. Again, this just gets distributed out. It doesn't matter where you draw your arrows. Sometimes you draw them on the top or the bottom, as long as you're showing that this is being distributed out to both the terms within the bracket. 2x times 1, well, we just have 2x. And 2x times negative x. A positive times a negative gives us a -2. And there are two lots of x's being multiplied, so this is where 2x squared comes into play. So it's 2x minus 2x squared. Alright, with C, we're distributing out 2/7 to 14x and 2/7 to 3. And your multiplication of fractions still apply, the rules still apply. So 2/7 times 14, the 7 cancels out, so this will turn into a 1, and that 14 will cancel down to a 2. So what we'll end up getting is 2 times 2. So this will end up being 4x. If you want to write this on the side, 2/7 times 14/1 cancels to 1, cancels to 2, so we get 2 times 2/1 times 1, or 2 times 2, which is 4. And because we have that x there, we have to make sure that we remember to put the x. And 2/7 times positive 3 is this 2 times 3, which is 6. So it's 6/7. So this is our simplified version. This one here, we've got two sets that we've got to expand out, and then we're going to simplify where it's possible. So just take this step by step. X times 2x is equal to 2x squared. X times -1 is just -1x or -x. Minus x times a positive 3 gives us minus 3x. And a minus x times another minus x, so two negatives make a positive, so it's x, and there's two lots of them, so it's x squared. So now we just need to do a bit of tidying up, so we're going to simplify where possible, or in other words, we're going to collect like terms. We have 2 lots of x squareds here, and we have 1 lot of x squared there, so 2 plus 1 is 3, all up we have 3 lots of x squareds, and we have a minus x minus 3 lots of x, so minus 1x, and then take away a further 3x gives us minus 4x. And this is our furthest simplified version down that we can get to. Okay, we're going to be expanding binomial products, perfect squares, and difference of perfect squares. And I've put these little two facts here to help us with B and C respectively. For now, let's have a look at A. A doesn't follow any of these formats here because these terms, even though the first term, the x's are the same, the +5 and the +4 are different. So we're just going to expand accordingly, first outside and then inside last. And I'll draw my little arrows over there, just to indicate which order we're doing this in. So first one, x times x, that's x squared. Oops. Then black, there we go. This is x squared. X times 4, so 4x. 5 times x, which is the next one, so plus 5x. And 5 times 4, which is 20. And we're just going to do a little bit of a tidy up. We have x squared, 4 lots of x's plus 5 lots of x's, that's 9 lots of x's, and a little 20 tagging along. So this is our final answer. All right, next one we have x minus 4 all squared. Now, this is where the perfect square rule comes into play, because we have a term here and a term here that's been subtracted, and all that's been squared. So the key term here we're going to be looking into, or key equation, is turning this into this here. Okay, so we don't necessarily need to do the further expansion out using the arrows. What we can do is we can just jump straight into getting a squared. So a is the first term, which is just x. So this is just mainly x squared. We're going to be subtracting 2 times a times b. So 2 times a, which is just x, times b, which is just 4. 2 times 4 will give me 8. So this is just minus 8x. And then the last part is adding b squared. So 4 squared is 4 times 4, which is 16. And we've just jumped straight from one to the other, using this almost as a shortcut, because I know if I do the expansion part out, we're going to get this answer in the first place. So there's our final solution for B. Alright, question C, which is the last one. 2x plus 1 multiplied by 2x minus 1, both of them in a set of brackets. This right here is the difference of perfect squares. We've got a and b that have been added, like here, and a and b that have been subtracted, like here. So what we end up getting is whatever a is, all squared, so 2x all squared, and this is being subtracted, or b squared is being subtracted from it, so 1 squared. Now we can actually figure this out. Remember, when there is a 2 on the outside of the bracket, that gets distributed to both the 2 and the x within the bracket. So this ends up being 2 squared, which is 4. 2 times 2 is 4. And x squared, just leaving it as x squared, minus whatever 1 squared is, which is just 1. Because 1 squared is 1 times 1. That there is our final solution using the difference of perfect squares, or the DOPS rule. We've got a few more examples here. Expand and simplify. So now we're just using first outside, inside, last rule. Draw your arrows to indicate what's being distributed out. 2x times 3x is 6x squared. Now remember, you were multiplying time and time again. I see people putting 5x squared because they think they have to add 2 and 3. It's a multiplication. So it's 2 times 3, which is 6, and then the x squared. 2x times positive 5, which gives me 10x. Negative 1 times 3x gives us negative 3x. And negative 1 times positive 5 gives me negative 5. Do a little bit of tidying up. 6x squared, there are no like terms with the x squared, so that stays as is. Plus 10x minus 3x, we end up having plus 7x. So 10 lots of x's take away 3 lots of x's, gives us 7 lots. And then we have that negative 5 that tags along at the back. B, we have 2x minus 3 and x minus 2. Now there are different ways that you can approach this. You can either distribute the 2 out to this and then multiply that out, or you can distribute this out first and then multiply the 2. I like to do the latter first. That way we don't have to deal with complicated multiplications. We do this this one in here and then distribute that 2 out accordingly. Okay, so with this one here, just going to remember to draw the arrows. Okay, so this is equal to, so we'll have the 2 tagging out the front, x times x, which is x squared, x times negative 2, which is negative 2x, negative 3 times x, which is negative 3x, and negative 3 times negative 2, which is positive 6. Now we can just tidy this up a little bit. X squared minus 2x minus 3x, which is minus 5x, plus the 6. And now that 2 can be distributed to not only the first, not only the second, but all 3 terms within the bracket. So this ends up being 2x squared minus 10x plus 12. So all I've done is multiplied the 2 with every single term within inside the bracket. For C, we have got quite a bit going on here. We've got this set of expansion here and this set of expansion here. And we've got this pesky little minus that's here. Okay, what I'm going to do is, just to play it safe, if I see something that looks like this is a positive, yep, that's fine. I'm just going to put these little brackets here around like this, just to indicate that I want to work out this first, this second, distribute this negative to all of the terms after this gets expanded, and then simplify accordingly. So the first one, let's distribute 1, 2, 3 first, so first, outside, inside, last, x times x, which is equal to x squared, x times 4, 4x, 2 times x, 2x, and 2 times 4, which is 8. And this is being taken away by square bracket. Alright, gotta remember the square bracket first. First, outside, inside, last. And you'll see why I'm putting this square bracket here. It has everything to do with the fact that this is a negative. X times x, x squared, x times negative 5, minus 5x, negative 2 times x, minus 2x, negative 2 times negative 5, positive 10. Close this bracket. Okay, let's tidy up what we can within the brackets, and I might just do this as well. So we have x squared plus 6x, because 4x and 2x simplifies down to 6x, plus 8, minus x squared minus 5x minus 2x is minus 7x plus 10. Alright, now what we're going to do is, you got to remember that there is an invisible 1 that's in front of you, or next, that's associated with this negative. So we're minusing 1 lot of this, this, and this. So this is technically getting distributed out to every term that's within here. So this is x squared plus 6x plus 8 minus x squared plus 7x minus 10. Okay, so a negative 1 times x squared is negative x squared. A negative 1 times negative 7x is positive 7x, and a negative 1 times positive 10 is negative 10. And this is where we can now finally tidy up and collect our like terms. X squared, take away x squared, cancels out. 6x plus 7x is equal to 13x. And 8 minus 10 is negative 2. Alright, last set of examples before you tackle the set questions. Taking out common factors. So taking out common factors, or factorizing, is doing the reverse process of expanding. So we want to write this in a form that does have brackets. Okay. The tricky thing is, when you're looking for factors, especially when it comes to negative numbers, it can get a bit, not necessarily confusing or tricky, but knowing what factors to take out. In this example here, we have negative 3x and negative 12. The common rule is, if both terms or all terms within an expression here have negatives, we take a negative number out as a common factor. And this is going to sound like a contradiction, but it's the highest negative number that we take out. Okay, or that has the most, the biggest magnitude in the form of a negative. What do I mean by this? Because I don't want to use the term highest common factor, because that becomes a bit of a contradiction, and you'll see why. So with this one here, we have a negative 3x and a negative 12. The most common number, if we just disregard the negatives for now, between 3 and 12 is the number 3. All right, so we're going to take 3 out as a common factor. Because both of these are negative, negative 3 is the common factor between negative 3x and minus 12. Okay, so just look at the numbers solely as the numbers as positives, 3 and 12, take out whatever the highest common factor is, and then because they're both negatives, you put the negative in front. Then we're just going to divide each term by what we've just taken out. So negative 3x divided by negative 3, well, we're just simply left with the x, and that makes sense because if negative 3 times x, that will give us negative 3x. So we're doing the reverse process. And negative 12 divided by negative 3 gives us positive 4. So this is what's called the factorized version. This here is factorized. If you were to type this up into Microsoft Word, sometimes I put the little squiggly line. That's because the American writing uses the letter Z. The Australian and UK writing uses the letter S. Sometimes you might see me write the letter Z just by habit, because I always type up tests and stuff like that, and I always use the letter Z because I just can't be bothered dealing with changing it to an S. So either way, it's fine. But this is the factorized version of this here. In this case, the second case here, we have 20a squared plus 30a. Now there's two different components. There's the number component and the letter component that we're going to take out as a common factor. This one's relatively simple because both of these terms are positive, so we don't have to deal with pesky negatives. Okay. So the first one, we have the numbers. The highest common factor between 20 and 30 is 10. So if we take 10 out as the number component of a common factor, and the highest common factor between a squared and a is a. I can only take out one of the a's. I can't take out two of them because I won't have enough within here, and by two of them I mean a squared. Okay, so I can take out a as a common factor. What I'm left with is if I take 10a and I divide it into 20a squared, what I'll be left with is just 2a. And that makes sense. 10 times 2 gives me 20, and a times a gives me a squared. So this is correct. And what I'll be left with within 30a is just 3, because 10a times 3 is 30a. So this here, again, is our factorized version of this here. It's a reverse process of expanding. We want to put brackets there. Now, what happens if there are already brackets in the question? What happens if we've already got brackets? We're looking for common factors. We're looking for factors or any term that you see that are in common between two of the terms here. Now this one here, there is a commonality. What we have left is x plus 1. What we have what we have in common, sorry, is x plus 1. So if I take out x plus 1 as my common factor, or divide both of these terms by x plus 1, what I'll be left with within this bracket here is just this 2 and this negative a. And that's it. I don't need to put the bracket there because I've already got a bracket there, and the negative a. That's it. That's all there is to it. Because this term here, even though it's in brackets, it's still got a commonality between these two terms. So I've just taken it out as my common factor. So if you want to write that as common factor, this is a common factor. And what's left is just the 2 and the minus a. And that's our simplified version. That's it for these set of questions. This is exercise 5a. The log sheet and textbook and work solutions are up on Compass within the new topic 7 folder. You can go ahead, check the log sheet, see which questions you need to do, and I'll see you in the next video. Until then, tell you all. Yes, I got it under 30 minutes.